What if I told you the difference between a chatbot and a real AI agent comes down to a single pattern? It's called React. And once you see it, you'll never look at AI systems the same way again. So let's break it down. What actually is an AI agent? You're probably familiar with the flow where a user sends a request, the LLM uses a tool, and then spits out an output. But here's the twist. That's not an AI agent. That's just a fancy chatbot. By the way, I'm Frazer. I build AI systems, and this video, I'll show you how to build a real agent from scratch in pure Python, no frameworks required. With a normal chatbot, you ask, prep me for my next meeting, and it will just throw a question right back at you. Sure, what's the next meeting about? But a real agent, it looks up your calendar, pulls your emails and docs, and writes you a briefing, and suddenly you walk in fully prepared. Now that's in a completely different league. So what's inside an AI agent? I like to think of it like a pit crew. The LLM is the brain, the tools are the wrenches, instructions are the playbook, memory, the notebook, and the runtime/orchestrator keeps the whole team in sync. Together, those parts turn a chatbot into something that can actually reason, act, and adapt. Now, there are frameworks that make spinning this up dead simple, but I'm not going to use them here. Let me show you why. There are some amazing frameworks out there like LangChain, AutoGen, CrewAI, Small Agents, LlamaIndex. I've built with all of them. They are fantastic shortcuts, but here's the thing. These are only useful if you know what's happening under the hood. If you don't, you're in for a lot of pain when you start to build production systems. That's why today we are building one from scratch, so you actually see the fundamentals that power these frameworks. So what's the secret pattern hiding under all of this? It's called React, and it changes everything. React stands for reason plus act, and the name is the whole trick. Agents alternate between thinking and doing. The framework was first introduced in 2023 paper by Yao and others, and honestly, it's shaped how modern agents are designed today. First, you have a thought step, where the model reasons step by step, it's chain of thought. Then you have an action step, where it does something like calls an API or searches the web or queries the memory. And finally, you have an observation step, where it checks what happened and decides what to do next. And then it loops. Think of it like if you were packing for a trip. You'd first have a thought. What's the weather? Then you take an action by checking the forecast. You'd follow that up with an observation that it's cold, and then a thought again, what warm clothes do I have? Followed by an action to check the closet. And then finally, you have an observation that the jacket is in the storage, and you adjust accordingly. That's the loop right there. Thought, action, observation. Over and over until it's ready to give you the final result. But hold up. What stops it from looping forever and racking up a giant token bill? That's where design matters. Here's the thing. At its core, agent is just an LLM in a loop. The real challenge is knowing when to start. There are a few strategies for that. One is max iterations. That is, you could cut it off after 5 loops, for example, no matter what. The other option is confidence threshold. You stop when the model is sure enough. Third is an explicit condition. You literally tell the model when to wrap up. The balance here is key. Without these guardrails, you risk runaway loops, wasted tokens, and fake results. Now, enough theory. Let's actually build one in Python with nothing but a prompt and a loop. Today, we're going to build a React veterinarian assistant. But first, let's start with importing the dependencies that we need. For this project, we're going to use Ollama simply because I want everyone to have access to an LLM without having to pay for it. And Ollama makes this easy as they provide open source models that you can download locally on your system. For this project, we're going to use the GPT open source model of 20 billion parameters, but basically you could use any open source model, to be honest. And then we're going to set up the React prompt And the React prompt basically says that you are a helpful veterinarian assistant whose goal is to answer questions about animals and their health. You are to only answer if you know the answer. And if you don't know the answer, you say, I don't know. Answer the following questions the best you can, and you have access to the following tools. This is where we will provide the manifest of the tools. The tool input should be in JSON format. Use the following format. And remember, we spoke about the whole loop of thought, action, observation. That's exactly what we're doing here. We have an input question, then you have a thought step, an action step, an action input, and an observation step. And this step can be repeated n times. And finally, you have a thought that if you know the answer, provide the final answer. Right at the bottom, we have a little agent scratchpad where we'll basically write the thought and the observations back into the prompt to be provided back to the model. I think this is pretty cool when you see it in action, which you will see below. Before that, we create a few utility functions. One function for passing the action. So this basically takes the text or the output from the model. It checks for the last two action and action inputs, extracts them out, and returns them back. Then you have the savePass JSON function, which ensures that the text is safely loaded as a JSON object. We create a function for calling the tool, where we pass the action input, and the list of tools. Essentially, what it does is it figures out which tool is being called and pass the arguments to that tool to be invoked. And then you have the tool manifest. What this does is it takes the list of tools and it extracts the docs, that's this section here, from each tool, and the arguments, and it provides it back as a string. And finally, you have the execute React agent that takes an input as a string. It takes the tool manifest, the tool, and the max iterations. For this agent, we'll set that to 10. We have the little scratchpad here, the tools combined, so the tool manifest, the tool names that is extracted from the tools, and then we populate the React template with the combined tools, the name of the tools, the input, and the agent scratchpad. We then create a little messages array where we pass a role user and the content, which is the prompt. And then we create a chat response. This is essentially invoking the chat API of Ollama, which then invokes the model, passes the messages, and sets the options that we set here. I've set the temperature to 0.7 because I think that's a good balance between being too factual and being too creative. I set a context window of 4096 and a seed value of 42 so that I can get some predictable outcomes. If you scroll down, once the response is returned, we get a message, and from there we can extract the content. If the content contains the final answer, what we do is provide the final answer back to the user. If not, we extract the action at the action input, check if the action is present, and if so, do a tool call that is then fed back into the observation, that is written into the scratchpad, and then fed back to the agent. Now, the main part of the vet assistant, we set up a few tools. In this case, I set up two specific tools. One is the getBreedInfo, which takes the breeds as a string and the animal type as a string. It has some mock data, and in this case, I have only dogs and cats in here, and a few breeds of dogs and a few breeds of cats. If you scroll a bit down, you have the check symptoms method, which has animal type as a string and symptoms as a string. Again, mock data of dogs and cats with a few symptoms for dogs and a few symptoms for cats. We create a dictionary of the tools. And finally, we create the veterinarian assistant, which takes in the user query. It executes the React agent, which then returns a response. Now, let's see this in action. I've called the vet assistant here with, can you tell me something about my poodle? This is now running the loop, right, with the prompt, and it gives me an answer. I'm not going to read out this whole thing, but if you look closely, you will see that it has provided information about eye disorders and skin allergies. And what's interesting is that it has fetched this from our mock data, right? Poodles often can have face eye disorders and skin allergies. Now, to see that in action, I'm going to activate logs, right? And we're going to ask a new question. Why is my dog coughing? Let's see what's actually happening here, right? You have the prompt, and in there we have populated the tool manifests, followed by the tool names, as you can see here. Then we have the question, right? And the thought is empty right now. Then you have the first iteration, where basically it reflects or thinks about the question of the user. It realizes that it needs to call the check symptoms function. It knows what input for the check symptom should be. Then we call the tool use, where it uses this check symptoms with this input, and then comes to the observation that the symptoms are coughing, and the assessment is that coughing in dogs can indicate kernel cough or heart disease, which is interesting because this is also information from our function itself, right? And then it updates the prompt again, the same tool manifest, the tool names, and here's where it changes a bit, right? You have the same loop again, where you have the last thought, and then the thought or the assessment from the model, the action that was taken, the action input, and the observation. And then it runs an iteration again, where it now realizes that it knows the final answer, and then provides the final answer to the user. That's pretty much it. Simple, right? So even though the core idea of an agent is simple, just a prompt plus a loop, production-ready systems get complex really fast. You've got to juggle memory, orchestration, costs, and sometimes even multi-agent collaboration. That's what makes building the systems so exciting. And that's why starting from scratch is the best way to understand them. So yeah, turns out that agents really is just a prompt plus a loop. Simple, but once you see it, you can't unsee it. And if you want to build production-ready AI systems, that's exactly what I break down on this channel. Smash the subscribe button and let's level up together.